looking now at the assessment navigator component of the AutoScholar Advisor. So this component allows us to create multiple variations on a set of multiple choice questions, and it allows for these questions to be generated to the students, and the students go ahead and select their answers, and then the system will grade those students. So here we can see a set of 10 questions, and all these questions look different to one another. However, these 10 questions have actually been generated from a bank of just 4 questions, which we'll look at just now. Furthermore, each student that undertakes this assessment will have a totally different set of questions. So even though all these assessments are coming from just 4 questions that have been defined, there are multiple variations that are generated for each student, and each student gets a different set of variations from the other students. So let's look at how we can design that by this method. So here we've got our question editor. So first off, at the top here, you've got a set of questions, so you can define a question set, and then we'll have multiple questions within that set of questions. So we might want to organize the different topics into our courses into sets, and we can create question sets out of those. Of course, there's nothing to stop us having multiple question sets for the same concept in a course. So however you wish to structure it, that's up to you. But once we've defined a set, and we can add a set or delete a set here, then we can go on and add or remove questions to and from that set. So we can create a question code here, and then we create a statement for that question right here. So I've selected question 2, and you can see here that the problem is stated. So there's a car of a certain mass traveling at a certain speed. What's that vehicle's momentum? And you'll see here these strange looking tags. So between the angle brackets is the name of a variable, and we want to create variation in this question by varying these tags. So down here, or rather across here, in your question statement modifiers, you can see the same variables listed. So you can select these variables, so car type, mass, M car, and U car for mass of car and velocity of car. So for the mass of the car, we want to create a range of values, and we can specify that we want this car, and if you look at the problem statement, that mass is in kilograms. So we can think about values on the order of 2 tons to 3 tons, and we specify that this is a random range. So we want some number in the range, in this range between 2 and 3,000. We can specify the number of decimal places here as well. So we can generate a random number simply through filling out this form, and that's the variable for M car. Similarly for U car, so the velocity of the car, here that's in meters per second, so extreme low values here for some reason. That's just the way the question is set up. We can change that easily, so that's meters per second, so that's actually a reasonable velocity for a car. So that's just another example of using a random range type variable. And then car type, just to change the text in the question. So this doesn't really change the calculation, but it changes the way the question looks. So here, if we specify, instead of random range, if we specify that we want a list, then we can create a list of objects here. And these are just text entries, and they are separated by semicolons. So you just create a semicolon separated list here, and that's basically your question statement ready. And you can preview the question down here. So you can see a Mercedes-Benz, and you can see that's just one of the car types listed here. A Mercedes-Benz of mass 2149 kilograms, and we know that's in the range 2 to 3,000 kilograms, and it's traveling at 8.3 meters per second, and we know that's in the range for that we've specified as well. So what's the vehicle's momentum? So of course this is just mass times velocity. So this is going to be on the order of 17,000. So we can select that right there. And we can say we are 100% confident in that answer. And if we check the answer, then the system says, yes, that's the best answer. You've gotten a score of 6. And that score of 6 is actually for a base value of 5 for that answer. So the actual marks for that question is 5. But you've also gotten an extra bonus point because we specified we were 100% confident in that answer. So there's research to support that by adding confidence measures to multiple choice questions, we gain some measure of control over people guessing in a question. So if we chose the wrong answer and we said we were 100% confident in that, then of course that's the wrong answer, so that's not the best answer. So score is 0. So the value of this answer is 0. And also because we were 100% confident in our wrong answer, then there can't be a bonus to that. Whereas if we had something like a 40% confidence in that wrong answer, then that goes up to 0.6. So if you say you are completely unsure of your answer, in other words, this is a wild guess, then you get 1 bonus point. Going back to the correct answer, if we said we had no confidence in our answer, then we still get the value. So this is not punitive. So we get the value of the answer, but we don't get the bonus points. Whereas if we said we were only 40% confident in this answer, then we'd get 5.4. So you can read about the research behind using confidence measures. In setting up your questions, you can also just switch this off if you feel this adds too much complication. Also, you can switch off the comment so that you just have a simple multiple choice question here. But really, this is where there's a lot of value. So, of course, multiple choice questions have these difficulties of not being able to communicate as much as when you have some narrative from a student that shows the formulation and so on. So here's a chance for the student to provide you with some narrative to check on the method behind selecting an answer. So anyway, that's how you can preview a question, and you can view the variance on this question by spamming this refresh button. So as you click it, you can see different variations on that same question. So you just keep clicking here and it creates multiple versions or instances of that question. So that's how a question will look, and in fact we saw that in the beginning, right? You've got all these questions here, and of course there's more variation in here than we are seeing. Even though there's variation here, there's more variation in Selfassess, because that's actually choosing from all the questions in the set. So in the set, as I mentioned earlier, there are 4 questions, and you can have as many questions in here as you like. You can just add them, update, remove here, right? So we've looked at so far creating questions and previewing them and modifying those questions. Then of course in the options here we can also edit the nature of the answers as well. So here we have 4 possible answers to this question. All right, that's the question 3 selected. So here we are asking someone drops something from somewhere on this day and it falls at an acceleration of, and we are supposed to know that these things don't matter and that the object will only fall at the gravitational constant. or the gravitational acceleration. And we've got some possible answers here. And so we can see here 3 times 10 to the 8 meters per second. So that's close to the speed of light. So obviously that's also a velocity or a speed, right? So that's not going to be the answer. This is clearly an acceleration that we want. So of course it's a meters per second answer that we want. And in fact, just based on that alone, we could reject these. And anyway, the number you can see is the correct gravitational acceleration value. So that's our answer, and we've got that specified here. You can see that answer 0 has a score of 5, and here's where we specify how to generate that answer. So this is actually a function creation, and those of you who know some computer science will recognize this as an anonymous function declaration. So there's a function which is going to return some result here. So in this case, it's a simple text object, right? We are just returning the value 9.81 meters per second squared. So that's how we are defining this answer. And you'll notice here the number doesn't correspond to the position among these answers. This is something like the 4th answer, whereas it's marked as answer 0. And that's because in addition to the variation on the text of the question, the system will also vary the position of the answer. So of course it wouldn't help if we defined the answer in a fixed position for a certain question type, and then the students figured out that, well, it turns out for that type of question it's always in the 3rd position or whatever it is. So of course the system is going to vary where the correct answer is going to sit. So in creating our answers, we go over here and we can specify the score for the answer. And we saw earlier that the base score was 5 for these questions. But you may decide that there are other answers which, although they're not the best answer, perhaps we want to allocate some kind of credit for that answer. So these don't all have to be either 1 or 0 or 5 and 0. This can be whatever you like. And then here, there's, of course, a great deal of potential for creating functions, and we'll look at some other function types just now. And down here, we have something quite valuable, which is the comment. So we want the student to receive some kind of feedback. So in addition to yes, it's right, or no, it's wrong, we want to know what's wrong with our answer if it is wrong. And number 2, we also want to know what would be the best answer. So let's say we chose the wrong answer here and we said check answer. So you can see here it's saying it's not the best answer and the usual scoring. And then here, here's an explanation for why that's wrong. So no, the units are wrong. N is units, that's force. And of course, if I was giving feedback to a student, I would give more feedback than this. It's not just for that reason that you wouldn't choose that. But anyway, we are free to provide as much detail as we like. So here we can write whatever comments we like about this wrong answer. And then the system goes on to look up among the answers available which one has the highest score, and then what's the comment for that best answer. So here's the comment, yes, that's gravitational acceleration. So here it's saying, yes, that's gravitational acceleration. And you can see that's not a good comment for this, because somebody reading this, let's say the student is reviewing how they've done on this question. They see here, yes, this looks like it's making a sensible comment. No, you haven't got it right, the units are wrong, right? That's fine. And then here to get the comment, yes, that's gravitational acceleration. That doesn't really fit with the context of the student getting this wrong. So we want to create text here knowing that this correct answer might show up together with the incorrect answer as well. So you might want to neutralize the language here so that it fits well, whether it's being used for incorrect feedback or correct feedback. So that's how we can edit our answers, and we can have as many answers as we like. So this set of choices is not limited. And once you've edited your answers and questions, do check this or do click on this update button. So that will save that set of questions in your account. So of course, when you come in here, you can register for a new account, and then when you log in, it will load up that bank of questions and so on. Right, so that's the Assessment Navigator, and this is a kind of sister component to the what did we call that? The coursework scaffolding component, coursework connect or something like that. So this is a kind of sister component to that. This, or it's a child component of that. It will fit into that component. So you can add these questions to the resources for the various concepts that you're teaching in your course.